So moving on to question 3 in the May 2018 AS paper, vectors question. So probably in terms of explaining this, it will be good to draw the vectors. When you're doing the question in the exam, you don't really need to draw them in this case. We're going to draw the position vector 4i minus 5j, so 4 across and 5 down from the origin, and then we've got minus 5i minus 2j, so I'll put that in about here. This isn't particularly accurate, I didn't leave myself much room there, but that's not a problem. We'll just label this up a little bit. This is our origin. Okay, this is going to be point A, and this is the vector A, and then this is the vector B going to capital B. So clearly from this diagram you can see what they mean by finding the vector AB. We're going to be finding this vector here. Okay, if you've drawn this triangle out a few times, what you learn from this is that there is a kind of shortcut for finding the vector AB. There's a couple of different ways of seeing this, but the shortcut really is that, well, let's do the longer version. If you're starting at capital A and you go to the origin, you're doing minus A, okay, and then you're going from the origin to B, which is plus B. Okay, but this is normally kind of spun round and people kind of write it as B minus A. Okay, the order that you do that in doesn't make any difference. Okay, so when we start actually doing the numbers here, we just need to write B first, which is minus 5i minus 2j. Okay, but then we're minusing A, so it's important that you put that in a bracket. So we minus A, that's 4i minus 5j. Okay, so if we expand our brackets, okay, we're going to get minus 5i minus 4i, just putting the i's next to each other. Okay, and then I'm going to get minus 2j, and the important thing here is that this minus on the outside of the bracket with this minus next to the 5j, okay, is going to create a plus, so this is plus 5j. Okay, so collect our i's together and collect our j's together. This is the vector AB. Okay, and it looks right on the diagram, because what it's saying is that we need to go 9 to the left and 3 up. Okay, it's not an accurate diagram, but it gives you a sense that it's roughly correct. Okay, so that's part A. So part B, okay, we need to find the modulus of AB. Okay, modulus is just a fancy word here for the length of AB. Okay, sometimes it'll be called the magnitude of AP. There's lots of different words that will be used, but in this case it is just the length of a diagonal line, and we learned that at GCSE. It's Pythagoras, so we just need to do the square root of, well, as I say, when you look at the diagram, we're going 9 across and 3 up. Okay, so we just need to do 9 squared plus 3 squared. I could write that as minus 9 squared, okay, but you kind of get a bit fed up doing that after a while when you're doing Pythagoras, because all negative numbers, when you square them, become positive. Okay, so this is the square root of 81 plus 9, or just stick this in your calculator. Okay, if we do it without a calculator, we get root 90, and then we need to simplify that. It's going to be root 9 times root 10, and root 9 of course is 3, so it's going to be 3 root 10. Okay, but really under exam conditions, just pop this into your calculator and it will give you this simplified surd form for your final answer.